In this demo video, we will present a clever way of exploiting Java's built-in expression language capability built into a very common logging service called Log4J. Then, we will show you how the Morphisec Linux protector, also known as Morphisec Knight, stops this exploit variant. Since its original inception, the logging function has become prevalent in almost all production systems built on top of Java. Systems like web servers, databases, ERP, storage devices, IoT, and many others are now so complex and extendable that some of their components rely on services with this exact vulnerability. This is why Log4Shell was dubbed the biggest vulnerability of the last decade. To exploit such a vulnerable service, the attacker must do two things. First is to set a rogue Java naming and directory service to feed a maliciously crafted Java class from a rogue Java remote method invocation service, both serving from an attacker-controlled server. The second thing is to provoke any vulnerable logging service with a maliciously designed message to trigger a chain reaction causing the vulnerable logging service to blindly evaluate the maliciously crafted Java class of the rogue RMI and JNDI services. If this exploit runs on a vulnerable production machine, an attacker can further breach additional machines and services on the network. In this demo, the attacker will piggyback the maliciously crafted payload on a benign-looking HTTP request header. The attacker can easily bypass defense mechanisms like a firewall or WAF by adding one or more hidden characters or piggybacking the payload onto a legitimate message field, say a username. As such, we will use in this demo a ready-made JNDI exploit kit that is similar to the toolkits that cybercriminals use to attack vulnerabilities in systems so they can distribute malware or perform other malicious activities. Exploit kits are packaged with exploits that can target commonly installed software, and within those exploit kits, you can typically find different types of payloads that support various commands to run over data transport, serialization options. So, with these kits, it's possible to execute a dynamic array of command flavors over a wide array of covert channels to bypass most traditionally built security monitoring and prevention tools. This means that attackers with some reconnaissance can easily find the crack to run a weaponized code against a vulnerable system without getting detected. As it turns out, those traditional never-changing tools can easily be learned, perfected in advance at home, leaving the attacker to remain persistent and undetected for as long as they choose. Next, the attacker will piggyback the maliciously crafted payload on a benign-looking HTTP request dummy log header field. As soon as the request is sent, the vulnerable logging service on the victim's machine gets baited to evaluate the maliciously crafted message, causing it to download and run the malicious Java class. Doing so provides the attacker with remote access to the victim's machine. At this point, there's nothing to stop the attacker from further exploring allowed permissions into legitimate resources, such as stored credentials, network access, and so on. Next, we will set the Morphisec Linux protector into a blocking state, which will prevent the attacker from exploiting a pre-existing bash executable and turning it into a reverse shell. This shows that the protector can at one time allow trusted code to create and execute other trusted processes, while simultaneously block untrusted code from doing the same function. And in blocking it at the command entry point, the attacker is blocked before it executes, thus keeping the victim machine system secure. Since the random offset changes periodically, it means that by attacking this machine, the attacker would find it extremely difficult to guess how to fork a process, allocate memory, and read files on other machines or the same machine at a different time. This is how Morphisec Knight provides an ever-changing attack surface that traps attackers into thinking that protected APIs are the same, when in fact they periodically change by a randomly selected offset. Something that makes the Linux protector work well in both air-gapped disconnected environments such as OT or SCADA networks, having very low to no dependency on back-end system, as well as perfectly suitable IT Internet Cloud or on-prem connected devices. Reporting on attack logs to the Morphisec Security Center, as well as upstream syslog, connected SIEM, SOAR, and into other security systems to allow further orchestration or immune data toward other IT systems.